Right. In the previous class, we started BGP concepts and terminologies. We learned what is multi-homing, the advantage of multi-homing, the different ways in which the routes are being learned. We learned what is autonomous system, the difference between IGP and BGP protocol, and we also learned that BGP is a path vector routing protocol, and it is it is considering one autonomous system as one hop. So you can also call it as hop by hop routing protocol. One hop is not one router, it is one autonomous system. We also learned that where it is appropriate to have BGP. When you don't have much knowledge on attributes, then we should not go for BGP. And when we don't have multi-homing, then you should not go for BGP. Or if the router is poor in memory and processor, then we should not use BGP. On the other hand, if your autonomous system is a transit autonomous system, or if you have multi-homing scenario, or if you have policies in path selection like traffic engineering, then you need BGP. With BGP attributes, you can achieve policy-based path selection. Now, BGP uses TCP. If you take other protocols, they don't have this type of strong, reliable mechanism. Every protocol have got some reliability, but they have their own, like RTP, reliable transport protocol in EIGRP, guarantees the delivery of update. The reason is EIGRP works in IP layer. OSPF also works in IP layer. OSPF uses acknowledgement packets. So they both don't have any TCP based reliability. BGP has got no other routing protocol has got TCP based communication before peering. See, before two routers forming neighbor, the three-way handshake provides a connection-oriented relationship, reliable relationship between the peer, after which the BGP negotiation starts, like BGP open message, BGP confirm, notification, and updates and so on. So highly reliable TCP-based routing protocols are highly reliable. BGP is TCP-based application layer protocol. BGP uses port number 179. Now, it has got incremental and triggered update. Whenever a change happens, the change alone is sent immediately. Not the complete database is going to be sent, only the change. And because it's TCP protocol, there are keep alives sent between the routers every 60 seconds. The next thing is BGP has got rich in metric called attributes. And if you see BGP, this is the protocol that works over the internet. The routes of one big company, the network information of one big company, is carried to another company, another company, another ISP, another ISP throughout the world using this protocol BGP. If you take OSPF, they work within an organization. But BGP is very big. The Internet Protocol, BGP is an Internet protocol. These are all the three type of tables that we see in BGP. One is the neighbor table. As I said earlier, two routers will form neighbor when three-way handshake is successful, followed by BGP parameters that's supposed to matches. Only when they match, they form neighbor. Such established neighbors are listed in this table. The command that we use to see the neighbor table is show IPBGP summary or show IPBGP neighbor. Both can be used, but show, show IPBGP summary is the best command. You will see the real table. When you type show IPBGP neighbor, it will show pages of information for each neighbor. It won't be like a user-friendly table. So we mostly use this command show IPBGP summary. Next is the BGP table itself. What is BGP table? It is the database in which all the networks that are advertised as well as learned by BGP and via BGP, along with the attributes. So in BGP table, what do we see in BGP table is the networks that you may have learned from other neighbor, as well as the network that we advertise from this local router, and the attribute that is attached to each network. And if you have multiple paths, all those multiple paths with their attributes are shown in this table, BGP table. The command is show IPBGP. That's all. No, not summary. Show IPBGP summary is for neighbor table. If you remove that summary word, then it is BGP table. Show IPBGP. That's all. No summary. Just put show IPBGP. You will see BGP table, which has got all the networks that are learned and advertised through and by BGP. And then the attributes attached to them. Next is the routing table. The routing table will have the best path to each destination. As usual, any protocol you take, the routing table is going to have the best route given by the routing protocol. Now, my question. Come again? Yeah, if you have multiple ISPs, of course, you will have routes given by multiple ISPs in the BGP table. If both the ISPs give the route information for the same network, then whichever is satisfying the attribute, only those routes will be seen in the routing table. See, you may have two ISPs And both the ISP may give you how to reach Yahoo. But both the routes cannot be there in the routing table. BGP will decide according to the attribute. BGP will decide which one route to install into the routing table. Next, there are different type of message types: open message, keep alive message, update message, and notification message. Open message, as I said earlier, after the three-way handshake successful between two routers, the very first BGP packet that will be sent along with the hold time and the router ID is what called as open message. You see, like OSPF, BGP also will pick loopback interface address as its router ID. So using the router ID and the hold time, which is by default 180 seconds. With all this information, open message will be sent between the neighbors, followed by how long you will hold a neighbor when it don't send keep alive. Now keep alive is another packet which is sent every 60 seconds. That is to maintain the neighborship. If this keep alive is coming without any problem every 60 seconds, the neighborship will be continuing. If it stops coming for 3 cycles, 180 seconds, then the neighborship will be removed. Now, update message is the, as we know, update is nothing but what? The changes that happened in the path attributes or in the network. There is notification, update message. What is notification? If there is some error in a network, if there is a cable break, if there is an error in a path, it will be notified. Right? So this chapter was an easy chapter introducing us what BGP is. Let's go to next chapter. BGP is enabled between two autonomous systems so that the network informations from one autonomous system will come to another autonomous system. We call that BGP relationship as eBGP. But if you want that same information to be shared to the inside network of your office, you will be running BGP with the inside router of your own autonomous system. We call that relationship as IBGP. And that's what I said. If you want to bring other autonomous system network to the border only, then eBGP is enough. If you want to bring the other autonomous system network information even to your inside router, not just the border, even to the inside router, then you will have IBGP relationship with the inside router and the border router. We will be seeing that in the picture. If I need to put this in a simple word, IBGPs are BGP peering between the routers of same autonomous system. eBGPs are BGP peering between the routers of different autonomous systems. All right. So what is BGP peer? If two routers can negotiate and form neighborship, if two routers can do TCP IP three-way handshake. If two routers can establish TCP three-way handshake session, we call it as BGP peers or BGP neighbors. Here you can see BGP between B and C. Can they form neighbor? Of course they can form neighbor. Even though there is no BGP here, B can form neighbor with C because B and C are already reachable via OSPF. With the help of reachability, you can do three-way handshake, isn't it? You cannot do. Uh, See, OSPF is just providing you reachability between these two. But BGP is bringing the networks of this autonomous system to this router to this router. So BGP is carrying different network, OSPF is carrying local network. Now what is eBGP? As I said, if you run BGP between the routers with different network, different autonomous system, you see C and X. C and X are different autonomous system, eBGP. Yeah? C and X are eBGP. D and Y are eBGP. Okay, one thing you need to remember, eBGP neighbors by default need to be directly connected. They need to be directly connected. Whereas IBGP neighbor, internal border gateway protocol, do not have to be directly connected. And what is IBGP neighbor? BGP running between the neighbors within the same AS. Now,